Hello kids, this is Unit 1 from IGCSE Physics. Let me just write it down. IGCSE Physics course code 0625, right? This is the revision series. We're going to cover the topics very quickly. I'll get you through all the topics and everything, every important detail for the exam in a very quick run, right? Now, this is physics. What is physics? It is the understanding of how the universe works. We want to understand how matter and energy are interacting with one another. Uh, what is matter? Matter is everything that occupies some space and has a certain mass. So we call that as matter, and the absence of matter is called vacuum, right? Or space, we generally call it, right? And then we have the energy, that is the ability to do some work, to move an object, to interact with another object, or to change the state of an object, right? We'll talk about energy in detail in the topic of energy, right? And it is measured in joules, and we can say that physics is just the interaction between matter and energy, how these two interact with one another. Let's say we have a moving object, it has a certain sort of energy, we call moving energy the kinetic energy, and then when we move that object from ground all the way up, we say it has certain potential energy with which it can fall down and create an impact on the surface of earth. So we always see in physics, everything around us is always having some sort of interaction between the matter and energy, and studying all of that is considered as physics. Right now, to study physics, we have to understand that there's some things that we need to make a measurement for. We have to measure them, we have to count them. Other than that, it would be impossible to understand what is the actual value of something, or what are we trying to achieve, right? So for that, we want to measure some quantities called physical quantities. These are the actual readings that we take using some instrument or a tool, from which we identify that, let's say, what is the length of my screen. I'll be using a ruler, right? So ruler is the instrument, and length of my screen is the physical quantity, right? So we are taking a measurement as of now. So what are measurements? They're physical quantities that we try to measure, and those physical quantities are divided into two types. Number one is called the base quantities. These are the 7 fundamental quantities that describe the universe. Now, keep in mind, this is my definition of the base quantities. You will find so many ways to define base quantities, but no one's going to ask you about the definition. But generally, understand this, that this is the fundamental 7 quantities that we scientists have devised, upon which we drive the whole understanding of the universe, every process, every phenomenon that we see around it, right, around us. We want to measure, not just observe it, but also take measurements of what is happening, how much of it is happening, and what is going to be the impact, right? So for that, we take measurements, and those 7 quantities are: number 1, mass; number 2, length; number 3, time; number 4, temperature; number 5, current. And these 5 are in your IGCSE course, so please recognize their names, their symbols. Mostly symbols can be swapped with other symbols, but these are the common symbols that we use. But what is not changing is the SI units for these, right? So the SI units that are needed for IGCSE are kilogram, mass, second, Kelvin for temperature, and amperes for current, right? Now, the other last two, number 6 and number 7, is the amount of substance, which we call as moles. We usually study this in chemistry, but again, we also study moles in physics while discussing the properties of gases and matter. But that's not an IGCSE course. That's going to be in A levels. So we're going to skip this. And the intensity light is also in A levels. So we don't really talk about this in IGCSE, right? But these are all the 7 actual factual 7 base quantities that we have. Now, what are drive quantities? These are the quantities that are based on base quantities, right? In other words, they are taken out from the base quantities. Let's say we have area. So what is area? Area is basically length into width. So basically what we do in terms of area, let's say if I take the length of this object and the width of this object, that's also length, and this is also a length. We have different names for it, right? I mean, we say depth, we say thickness. So all these are basically names of all these quantities, right? So I'll write the example of over here. Like, let's say if we have length, we talk about length, right? That can be termed as diameter, right? Radius, so many names you can find. Height, thickness, wall thickness, depth, right? uh, so there's so many ways or names for one quantity, but the real quantity is eventually length, and that we can take out as an area over here, right? So area is a combination of this. And now let's talk about the volume, right? What is volume? We say that volume is basically the four types, right? V is equal to length into width into height, right? So I will call this length into length into length. Why? Because for measuring the length and the width and the height of my room, right, I will still have to use a measuring tape, right? So one instrument which measures length is making all three measurements. So keep in mind, these three are just names. Eventually it is just volume, right? And it is just length that we're trying to measure in three different dimensions. And as a result, it is also having a unit which is meter cube, while the unit of length purely is just meters, not meter cube, right? Since it's a multiplication, it's a product of three different types of lengths. Hence, meter cube is going to be its SI unit, right? So these drive quantities are all the quantities which we study in detail in physics. We get to know their units. We get to understand where they're used and how they are being employed in different calculations. Now, the important exam tip that I have over here is that whenever in a P6 or P4 or P2, they ask you about the word error. Now, keep in mind, error can never happen in a calculation. Why? Let's say if I tell you that the formula for force is mass into acceleration, right? Now the student has the acceleration value, but he's measuring this, right? Let's say this is measured. So in this case, if there is any error in there, it is going to be over here, right? This is going to be error sum, not the force and not the acceleration, because these are calculations. Okay, these are both calculated quantities. It's the mass that was measured, and that is going to be error sum over here, right? So if there's any error stated in the question, that should be in the measurement, not in the calculation, right? I see a lot of kids responding several questions suggest, right, especially in the P4 and the P6, where you're asked for a suggestion of what the measurement is, or how accurate the measurement was. I see that most of the kids are referring to calculated values, right? You are not supposed to talk about calculated values. They cannot have errors. They can have the after effect of errors, right? It is the outcome of the error that you see in the calculation. The error is always in the measurements. Okay. Now moving on, why do we need the SI system? The ones that we're talking about, the SI units and all, right? We need the SI unit because we want everyone around the world to have the same tools and units for sharing values and readings, right? Let's say if I have a different idea of what is the length of a meter. Let's say for me, the meter is this big, right? This is 1 meter, but in Europe, the meter is this big. Then obviously, if I take a measurement out of my room using my ruler and the one from the Swiss, that is going to be entirely different, and we cannot have that. That is why the whole world will use a standard, right? So this is a standard that has been kept by the Museum of the System International in Switzerland, and those standards are the very references that we use for making all the meter rulers around the world, or any measuring tape and whatever that we have, like the length measurement tools that we use. They are all relative to this one standard of 1 meter that is there in the Museum of System International, kept there as a relative base to adjust or calibrate other instruments, right? Or to make sure that the other instruments are equally accurate as this one, right? So we take replicas out of it. Okay, now how do we write numbers in IGCSE physics? We tend to write larger or bigger numbers in terms of standard form, right? In which we try to write a very small number, like this decimal number that we have over here, 0.0056, right? Now that's a very bad way of writing number, right? Instead, I would try to remove all unnecessary zeros and try to adjust the decimal place to the first non-zero decimal position, right? The first has to be non-zero. If it is a zero, it is not significant, right? Please recall the rules for significant figures. That's general scientific method done in maths, done in chemistry, and all other subjects, and as well as in grade 8 checkmark sciences. You already get to know what significant figures is, right? So we need to write at least 2 significant figures for your paper. 3 is not recommended. This one is 3, just to give you an example. Here's another one for 2 significant figure, which the usually paper demands from you, right? So let's say you have a very small number. you have all these 4 zeros which are not significant. We are going to move the decimal all the way to the first non-zero. It is going to be 1.793 into 10 to the power minus 5, right? Now over here, since we need two significant figure as a requirement for IGCSE program, now keep in mind these notes, as I said, they are same for all IGCSE programs, whether it is Cambridge, Edexcel or Oxford. But as of now, I'm focusing entirely on the Cambridge IGCSE. So we need to focus on just two significant figures. Three are accepted by other boards. Cambridge does not accept three significant figures, right? So we have to convert all our numbers into two significant figure values, right? Even if it's, let's say, if it is 5600, then let's say, sorry, if the number is 5697, then I need to round it off up to two significant figures. In other words, my answer is going to be 5700. Why? This will round off, giving +1. This will also round off, giving +1 to the other one. And then we're going to get two significant figures here. And these are trailing zeros, right, which are not significant as of now, but usually since they are 1000 or representative of 1000, so we count them in, right? So make sure your answers are converted into two significant figures. In this case, you can see that the 3 was rounded off, but no addition because it's less than 5. And now 9 is rounded off to into 7, so that's going to be a +1, right, because it is greater than 5. So the actual correct answer is 1.8 into 10 to the power minus 5 is the real or the correct answer that your examiner will accept, right? Now these are other examples over here. You can pause the video and have a look at it. I'm going to move on forward to discuss few important terms which are used in the questions that are not explained very well, right? So over here we have important terms related to measurements. We have readings, right? What is a reading? It is the value that has been observed from the instrument, the value that we note down from an instrument, right? Then we have resolution. Resolution is the least count. It is the smallest possible reading of an instrument that it can read, right? For example, for the meter ruler, it is 1 millimeter. For vernier caliper, it is 0.1 millimeter or 0.05 millimeters. And for the screw gauge, which is able to read even smaller values, it is 0.01 millimeters, right? So that's the smallest possible value an instrument can read, right? And now range, that's the maximum possibility of an instrument to measure the maximum length, right, or the maximum value it can take. For example, I have a thermometer in my room that reads a maximum of 100 degrees Celsius. If it goes above than that, it will get damaged. So that's the maximum range, right? So it reads from 0 degrees Celsius to all the way 100 degrees Celsius. That's the range of it, right? It has a range of 100 degrees Celsius, right? So maximum value that is possible. If I have to make a reading of 150 degrees Celsius, then my thermometer, which is inside my room, is not useful for it, right? Because it does not fall in the range of the requirement, right? Now, next term is accuracy. This is the closeness of values to the target. And over here, you can see these values, right? These ones, the green ones, right? You see that two of them are hitting the red target, which is the target. The third one is very close. Fourth is far away. But since we have two of them hitting the target, we'll see that this is accurate. Now, what is precision? It is the closest of values to each other. Now, you see that this yellow one, it is precise, but only one of the target is hitting the actual target, right? The red one inside the red ring. So only one is touching the target. The rest of the three are not close to target. But since they're close to one another, we'll say that this is precise and this is accurate. And if I wanted to mark what you say as reproducible or highly reproducible result, that is going to be both accurate and precise, right? So this is going to be, you can say, reproducible, although not asked in the paper. So I'm just putting it over here as a word, right? These pink dots are going to be your reproducible target. Why? They are both precise and accurate, right? It is both precise and accurate. That is what you call as reproducible results, right? Now, three more terms that are there. Number one, human error, right? It is caused by the observer. Let's say if I'm not reading the ruler very correctly, if I'm having a wrong angle of reading instead of the pure 90-degree angle or the perpendicular angle need to have for the ruler. So that is caused by human. Number one, the method should be altered to reduce human error or omit human error entirely, or remove human intervention or a human connection to that value. Let's say if you're using a stopwatch, use light gates, right? Light gates automatically note the time of moving objects, so you don't have to click start and click off the stopwatch. That might have human observation error. So you can reduce human error entirely by using a different instrument, or you can take the values of several readings and then take an average to reduce the error, right? So make sure you understand that this error can be reduced. It is not an issue. We can reduce this error by taking several values, multiple readings, and taking an average. Now, systematic error is also there. This is caused by a faulty instrument. Let's say if an instrument is not able to fully close its jaws, or it's not fully able to read it. Let's say if I have a stopwatch, it does not start from 0, right? It always starts from 5. The moment I press it, it starts immediately from 5 instead of 0. So that's a 0 error, right? It's not entirely on 0. Or let's say while measurement, it takes a jump somewhere, or there's a glitch in the instrument, right? So any fault in the instrument may cause issues in the reading. What we can do is that take 0 corrections for it. Now in your course, you only have 0 corrections. Just for the sake of theory, I don't think there's any link to 0 corrections in either of the paper P2, P4, or P6. Edexcel students, they do have to calculate systematic error and fix it as well, right? But not for IGCSE streams, Oxford and Cambridge, right? They don't have it. Now finally, we have the last term, random error. This is caused by environmental factors. Again, how to fix it? Take the average of several readings and reduce it, right? That's how you will reduce the possibility of random error. Now keep in mind, random error is unavoidable, right? So I'm going to put it over here that this is unavoidable. It can happen to anyone. So we can't say that it's a problem with the method, or it's a problem with the person taking a reading. It could happen because let's say you were running an experiment out of nowhere while you were taking a reading, wind blew up and it altered the effect, right? It had some effects on your measurement. Let's say you were looking to see the movement of an object while you threw something upwards, right? So when you threw something up, the air moved around, and it's going to cause some variation in your results, right? So that is called random error, and the only way to reduce it is by taking average of several values. That should reduce your effect, right? Now in IGCSE courses, all of them, we have multiple instruments. We'll see one instrument in one qualification and one in the other, but generally I'm going to give the introduction to all of them, because they can ask you for any of these if they provide you a diagram. Yes, without the diagram for IGCSE Cambridge, you're not going to see the vernier caliper, but I've seen that they refer to vernier caliper in P6 by making a diagram, even though it is not part of your course, but they can ask you this if they provide you a complete scientific scenario for this, right, along with the diagram. So you can't claim that you haven't studied this, because they're not asking you to understand the vernier caliper. They're asking you to observe what the reading was taken and what could be the other factors, right? So they'll narrate the whole question for you. So the tools that we use for length measurement, number one, ruler. Now keep track of the range and the resolution. Again, range is the maximum. You can say the application for which we can use it. So a ruler can be used up for the objects which are up to 100 centimeter, or let's say 1 meter, right? So any object that is within 1 meter, I can use a ruler to take its measurement, and its resolution is 1 millimeter. So it cannot take a reading less than 1 millimeter, right? If an object is smaller than 1 millimeter, let's say my hair, like a strand of hair from my head, I cannot measure it using the meter ruler, because that's too small of a value for the meter ruler to note. That can be done with vernier caliper. No, it cannot be done with vernier caliper, because again the resolution is just 0.1 millimeter, and that is still too small for the instrument to measure. And it has a maximum range up to 15 centimeter, or some are there up to 20 centimeters as well, right? No more than this, because this instrument is designed to take on smaller objects, right? Let's say bearings or small wires, you want to measure the length or the thickness or small fragments of an object, right? So use vernier caliper. Now we have for larger measurements, let's say if an object is 10 meters or more than 10 meters or anything above 1 meter, we need to use measuring tape. or measuring wheel if the value is slightly larger, right? Let's say if it's the length of my room, I'll take a measuring tape and take readings, right? But if I have to measure the length of a football ground, I can't use measuring tape because it has again, it has a certain limit. Most of the measuring tapes that you find in the market are up to 30 meters maximum. Rarely you will find a 40-meter or 50-meter measuring tape. And again, a football ground is about 100 meters long, so you still can't use a measuring tape. You'll have to use a measuring wheel, right? So the diagrams are attached for you to understand like how these instruments look. They don't ask you to draw and they don't ask you to explain anything. You just need to remember what the instrument's operable range is, right? I mean, it can be used for less than 1 meter as well. I mean, for my let's say my screen, I can measure the length using measuring tape as well. So keep in mind, measuring tape and ruler both have same resolution, except the measuring tape is able to measure larger objects as well. Ruler cannot, right? Ruler cannot go more than 1 meter. It can take smaller as well as the larger objects, right? Now, finally, screw gauge. This is in IGCSE Cambridge only. Rest of the qualifications, they also have vernier caliper, right, along with the screw gauge. So screw gauge has the resolution of 0.01 millimeter for your course. There are others which are even lesser than that, right? You can even get 0.005 millimeter, right? But that's not included in your course. The one provided to your course as per your lab list is basically this one, and it can take objects up to 2.5 centimeter, no more than that. Why? Because that's the size of this anvil in which you can place your object, right? And that's the maximum value you can take out of it, right? Now, taking length measurements. Let's say there's a question in P6, a student measures the length of a pendulum. How can she make accurate measurements? Now, whenever this is asked, accurate measurements, make sure you narrate the process or you identify the process of how you can measure the length correctly. Let's say what errors can be there. Now, this is you can say human error, right? That the student is putting the ruler, but it is not perfectly aligned to the thread, right? So how can you be sure that the measurement you're taking is correct? So your ruler needs to be 100% parallel to the thread. Now, how will you ensure that this is parallel, 100% parallel? You need a set square to do that, right? And that's the key takeaway, that you need set square for vertical alignment. And viewing error, make sure that you're reading it at the 90 degrees or perpendicular to it, right? If I read, let's say if I'm reading the value from here, that is correct. If I read the value from this angle or any other angle, that would be incorrect. This would be correct. So eye level needs to be maintained, which we call as perpendicular to the markings, right? So the markings are like this. So we need to be perpendicular to this ruler so that we're able to read the markings correctly, right? Now, few examples are there. We can cover these examples more in detail using the topical past papers, but just giving an example that wherever they ask you to take length measurements and they want you to make sure that this is highly accurate, see if it is a physical ruler and the object is placed against a ruler. Always use set square so that you have the exact value. Otherwise, you can have wrong angle of measurement, right? To make sure that you're reading correctly, use right angle triangles provided to you in the set square, right? There are two of them. Both of them have a 90-degree angle, so you can place them against the ruler. So here's your ruler, place your triangle and then place your object. Now place the other triangle to close the loop and then take the measurement from this, right? They should give you the actual or the very accurate length measurement, right? Again, use of set square is the set answer that is required by Cambridge examiners, right? Okay, and also applicable to Edexcel and AQA board. Now, finally, we have measuring volumes. There are several ways we can measure the volume. You'll be expected to recognize all of these volume formulas, which are coming from maths grade 7, 6, 7, 8, right? You should already know. What we are going to be concerned with is measuring the volume of irregular objects, right? Objects that cannot be defined using a formula in terms of their volume, right? For that, we use an instrument called measuring cylinder. Now, measuring cylinders are available in several readings. Now, keep in mind, each one has its own resolution. The smaller the object becomes, the more resolution it gets. Let's say I have a measuring cylinder that is for 1 liter. and a measuring cylinder that is only for 10 ml. Obviously, the 10 ml is going to have much more smaller markings, and this is going to have bigger markings because this is too much of a volume to divide it into smaller parts. It will be very difficult for us to read at least 0.1 ml out of it, right? But on a 10 ml, on a smaller one, I can make smaller measurements as well. For the larger one, you can see already that the markings are bigger and for larger volumes, right? For larger, let's say 10 centimeter cube is each marking. For this one, it is going to be 0.1 centimeter cube, right? So for your paper, the smallest resolution that you get in your paper is basically 0.2 ml, right? Or 0.2 centimeter cube. Let me write it over here, right? So the least count for paper, right? Mostly the one that they give you is either 0.1 centimeter cube or 0.2 centimeter cube. That is evident from the diagram, right? Rarely they give you 0.5 or 1 centimeter, right? It could be 0.5 or 1 centimeter cube as well, depending upon the question or the scenario that they're giving you. But that's the lowest resolution you can get, 1 centimeter, and the smallest one or the most best resolution you can get is 0.1 centimeter cube. Below than that is not in your course outline, right? So no need to worry about it. Again, how to make sure there is no human error? Number one, always view the water level at eye level, right? And secondly, you have to account for the curvature. So whenever you add a liquid in a thinner tube, you will find that it forms this curvy look, right? This is called meniscus, right? Meniscus. And this meniscus is the curvature of water in a in a smaller tube. Now keep in mind, if the object is larger, then the meniscus is less prominent, and if the object is let's say or the measuring cylinder is a narrow one, then you're going to see more prominent meniscus, right? So we'll say that wider gives less prominent meniscus, and narrow one will give you more prominent meniscus, right? And keep in mind, we always measure the value from the lower meniscus, not from the upper meniscus, right? So let's say if this is your liquid level, oh there, right? Oh, okay. So let's say you have a cylinder that is going to, oh, it's not getting straight. My apologies, right? So this is meniscus, right? So this is the lower meniscus, and this is the upper meniscus. So this is the correct one. This we don't take, okay? And this has to be read at eye level. Again, eye level needs to be maintained, right? How to measure the object of irregular object? That was the question. What you do is that you take a measuring cylinder, fill it up with certain amount of water, note the volume, hang your object using a thread, immerse it inside the liquid. You'll see that it will displace the liquid and the liquid volume will rise. Note the new volume, take the difference of these two volumes. That should be the volume of this irregular object, right? Now this is using a measuring cylinder. We also have something called liquid displacement flask, right? This is a flask which you fill it up to the brim, and any excess water that you put in gets wasted out. So what we do is that after filling it up to the max level, we add or hang our object inside it and put a dish over here to collect the water that is going to fall off, right? Once we immerse the object into the water, it will displace the water. Now the water cannot rise up in the level because there is a spillway. So out of the spill tube, it will come into this beaker. We collect the water in the beaker and measure it is using any accurate, high accuracy or high precision measuring cylinder, depending upon how much volume did we collect, right? If it's a small volume, we can use a 10 centimeter cube. If it's a large volume, we can use a 100 centimeter cube. And if it is even greater than that, we can use a 500 centimeter cube or 1 liter centimeter cube measuring cylinder, right? Whatever the amount of water gets displaced. Now, why this method is required? Not discussed much in your book, but can be used, right? Reason being, not every time that your irregular object is of the size which can be inserted in a measuring cylinder. Now keep in mind, measuring cylinders have narrow openings, right? So if I have, let's say, a brick, then the brick is too big for the measuring cylinder to fit in, right? For that, I will need this displacement flask, which is very wide in area. So this makes it easier for us to measure the volume of an irregular object, okay? Now, also we have link from this chapter up to chapter number 5, which is density, but I'm adding it over here because mostly whenever we're doing the topical questions for unit 1 measurements, we mostly get display density questions along with it, right? So what is density? Density means how many particles are there in a given space. In other words, how much mass is there in given volume, right? Or the ratio of the mass over volume is called density, right? And for us, the standard for density is water, which we usually take 1 gram per centimeter cube or 1 kilogram per centimeter cube. This is SI unit. This is lab scale, right? At lab scale, we use this scale. And for SI or exam, we use SI. But make sure if they demand you for this one, you must convert it down, right? So that's the conversion, that 1 gram per centimeter cube is equal to 1000 kilograms per meter cube, right? So 1 gram per centimeter cube is this much, this small little cube, and that one is quite large, right? Very big cube, so you can get 1000 of them, right? So roughly you can say 1000 liters of water is equal to 1000 kilograms of mass, right? And anything that is lighter than mass, or less dense than water, it will float. Anything that is denser than water will sink, right? That's why we use water as a standard for making relative measurements for density, right? Now I have certain questions, some examples solved over here. You can pause the video and have a look at these examples and solve them, right? If you want to, and if you get any query, you can post it in the comments. Now I'm going to quickly rush through the last two measurements that are taken in unit 1, which is measurement of mass. We are mostly asked about the question, which instrument is used? We use digital balance for IGCSE programs only. We have other ways to measure mass, but this is the one that is for your paper. And how do we do it? That we place the object on the digital balance, tear it up, and then we take the reading. Now the reading is provided on the display, so there's no human error involved over here. That is why we prefer digital instruments, because it removes human reading error, right? It's a display, it gives you the exact value to note. Now most of the time they ask you for the nearest gram or nearest kilogram, so make sure you convert or adapt or round off your value to the nearest whatever unit they are asking for. Now keep in mind, this 0.2 over here is not a gram, it is 1/10 of a gram, right? It is decimal place of a gram, so it is not a gram, it is 1/10 of a gram. Okay, so we are not going to note it when we say nearest of a gram. That's the actual reading including that decimal value, and this is the nearest to gram, which is going to be 96. If let's say it were 96.7 grams, then the nearest gram would have been 97 grams. Why? Because it will now get rounded off, right? So make sure you round off your values to the nearest whatever unit they ask for, not just necessarily gram, could be kilogram, right? And just a simple conversion, unit conversion, we have 1 ton is equal to 1000 kilograms, 1 kilogram is equal to 1000 grams, 1 grams is equal to 1000 milligrams. Okay. Finally, we have measuring time, and we have two instruments that we can use. One is analog stopwatch, the other is digital stopwatch, and digital stopwatch is more accurate and better in resolution. Other than that, going into further detail of time measurement is much futile, because with every question there's a different diagram and there's a different resolution. So I'm not going to cover that as of now. We will rather cover this with topical questions, right? Thank you so much for your time. If you got any queries or any specific information that you require or detail you require from this topic, this is a quick revision session, so post it in the comments. I'll try to make a short video for you, or at least respond back to you to help you understand better. Thank you for your time.